Welcome to the Deep Dive. We dig into the sources so you don't have to, bringing you the key insights you need. Today, we're diving into large language models. They're amazing, right? Transforming everything. But, if you've ever had a long chat with one, a really long one, you might have noticed things get a bit fuzzy, like the model forgets what you talked about 5 minutes ago, or just gets overwhelmed.
Oh, absolutely. That's a really common feeling. It points to a core technical hurdle. Most current LLMs use something called full context prompting. Basically, they tack on every single turn of the conversation to the history.
Just keep adding it on.
Yep. Simple, but it creates this unbounded context problem,
Hmm.
especially for transformers. The tech behind most big models, the compute costs, they just explode. It's ONN for compute.
Okay, but remind us why that's such a big deal. It's not just slightly slower, is
No,
it?
no, it's fundamental. Doubling the chat length means quadrupling the compute needed. And memory use scales too, ON. So you hit a wall, you need massive GPUs, you waste resources, and frankly, performance tanks as the conversation gets longer.
Right, it just gets overloaded. So are we stuck?
Mhm.
Are long, complex AI conversations just not practical?
Well, that's exactly the question M1 is trying to answer. It's a really fascinating new approach. And today, that's our mission, to unpack MM1. How does it manage constant memory? How does it boost performance so much? And maybe the coolest part would be these surprisingly human-like behaviors that pop up. You'll want to hear this. It really could change how you interact with AI down the line.
Okay, MAM1. But before we get to the solution, let's dig a bit deeper into the problem. Why exactly do current LLMs struggle with this long-term memory? We've got the spiraling costs. What else?
Right, besides the huge resource drain needing tons of expensive GPU memory, there are two other major headaches. First, generalization limits. If a conversation gets longer than the data the model was trained on.
Ah, so it's like going off the map. It doesn't know how to handle it.
Exactly, it's out of distribution.
Yeah.
The model just struggles to reason effectively over these super long inputs it hasn't really seen before.
Okay, that makes sense. And the third problem, you mentioned context getting overloaded.
Yeah, that's the other big one. Even if the model could handle the length, just dumping everything in means the context gets filled with, well, junk, irrelevant stuff, repeated information.
Like trying to have a serious discussion in a room where someone keeps shouting random facts.
Sort of, yeah. It dilutes the model's attention. The important bits might be in there, but they get lost in the noise. Finding the needle in a haystack, and the haystack is growing with every turn.
And existing fixes, like maybe summarizing or using external memory, they don't quite cut it.
They often help, but they usually operate separately. They're bolted on, not really integrated with the AI's core thinking process. Adds complexity, hard to optimize end to end. So the core question MEM1 tackles is, can a model learn to manage its own memory, consolidate it as it reasons, keeping only what's essential?
That sounds like, like how we think, right? Not remembering every single word, but the gist, the important connections.
Precisely. And that's where MEM1 gets really elegant. The name's a bit technical, memory-efficient mechanism via learning one-step integrated reasoning and consolidation, but the idea is spot on.
Okay, break that down. How does it actually do that?
So at each step, instead of just adding the new info, MEM1 updates this thing called a compact shared internal state. Think of it like...
More like it's working memory. It's scratchpad.
Exactly. It's not a separate memory bank. It's integrated.
Huh.
It supports both memory consolidation and the reasoning needed for the next step. It takes the old state, mixes in the new observations, and this is key. It strategically discards stuff that's now irrelevant or redundant.
Ah, so it actively forgets the noise.
Right. Which stops the prompt from just ballooning. You get near constant memory usage. It's a totally different approach from just letting the context grow and grow.
That sounds incredibly efficient. How is it trained to do that? Does it get a reward for saving memory?
Interestingly, no, not directly. It's trained using reinforcement learning, RL. The rewards are purely for succeeding at the task, like answering the question correctly. But to succeed at complex, long tasks, the agent effectively learns that managing memory efficiently is crucial. It becomes part of its winning strategy.
So it learns good memory habits because those habits help it win. That's clever.
It is. It's a bit like, how people get better at remembering things by doing puzzles like Sudoku or crosswords. You're not explicitly training memory, but you learn to focus, to hold relevant bits, to connect things.
Which makes you better at the puzzle and indirectly improves how you manage information.
Got it. Exactly. That kind of emergent skill development.
Okay, the theory sounds great. Near constant memory, learning what to keep. But does it actually work? What happened when they put MEM1 to the test, I heard they used some tough benchmarks.
They did. They cooked up some really innovative tests. They took existing question answering data sets like Hotpot QA.
Those are the ones where you need to combine info from different places, right? Multi-hop QA.
Precisely. It's like a mini detective job for the AI. They chained these questions together into long sequences, sometimes up to 16 objectives. This really forced the agents to manage memory over many, many turns, much more like a complex real-world problem.
16 objectives. Okay, that sounds brutal. How did MEM1 handle that compared to, say, a standard, bigger model?
The results were, frankly, stunning. On that 16 objective task, MEM1 7B, that's a 7 billion parameter model, performed 3.5 times better than a standard 14 billion parameter model, Qwen 2.5 instruct.
Wait, 3.5 times better performance from a model half the size.
Yep, and at the same time, it used 3.7 times less memory.
Wow. Okay, that's huge. Better performance and drastically low resource use.
It really highlights the power of efficient thinking over just raw size. And what's more, MM1 generalized really well. It was only trained on tasks with, say, 2 objectives.
But it aced the 16 objective one.
Exactly. And its peak memory usage, the maximum tokens it needed, stayed almost flat, even as the task got way longer. Other methods saw their memory needs just climb linearly.
Just look at the efficiency numbers you said on that big task. It only needed about 27% of the peak tokens and under 30% of the inference time compared to the bigger model.
That's right. Massive savings in compute and time.
Okay, so it crushes complex Q&A. But many real tasks involve interacting with dynamic environments, like browsing the web. Did they test it there?
They did, using the web shop environment, which simulates online shopping tasks. MEM1 Web Shop blew away other agent training methods like Agent LM. We're talking almost 3 times better peak token usage, nearly 2 times better on something called dependency.
Dependency. What's that measure?
It basically tracks how much the agent relies on the full, long history versus its compressed state. Lower is better, means it's using its memory efficiently. And it was 1.5 times faster in inference time than the best baseline. It even outperformed Agent LM13B, again, a model twice its size.
So smarter and faster across different kinds of tasks, even standard single-question tasks.
Yep, even on simpler QA like WikiRag and online web QA, it showed better efficiency, lower tokens, dependency, time. And it showed strong zero-shot transferability.
Meaning it could handle totally new websites it hadn't been trained on.
Exactly. It learned the skill of web navigation and memory management, not just memorizing specific sites. Really shows how robust its memory system is.
Okay, the efficiency is undeniable. But you mentioned something earlier that really caught my ear, these emergent behaviors, things that make it seem more intelligent.
Yes. This is where it gets super interesting, especially for you listening. It's not just about numbers. It's about how MEM1 seems to think. For instance, managing multiple questions at once. It learned to keep track of different goals, updating separate memory streams for each.
Like juggling different tasks in your head.
Kind of. And that led to other cool things, like shifting focus. If it got stuck on one hard question, it could recognize that.
And switch to an easier one it could actually make progress on.
Precisely. Strategic prioritization. And it learned to interleave reasoning and memory. It wasn't just storing facts. It was actively pulling key info from past searches, weaving it into its internal state, and using that to figure out the best next query.
So it's constantly thinking, okay, based on what I just learned and what I already know, what's the smartest thing to ask next?
Yes. It explicitly reasons about how important new information is before deciding whether to integrate it. It's a much more active memory process.
That sounds much more like how people research things, doesn't it? Not just grabbing everything, but filtering, synthesizing.
It really does. And other general strategies emerge too, like self-verification, going back to double-check things if it suspected an earlier mistake.
Oh, interesting. Correcting itself.
Yeah, or decomposing a big, complex query into smaller sub-goals before searching. Iterative search, using info from one search to refine the next one. And even rescoping if a search was too narrow and failed, it could broaden the query.
And the key thing is nobody programmed these strategies explicitly. They just emerge.
Exactly. They emerge from the RL process of trying to succeed at the tasks. That makes them adaptable, insightful in ways that hard-coded systems often aren't.
Okay, let's recap this deep dive then. MEM1 seems like a major step forward. It manages this incredible balancing act top-tier performance on really long, complex tasks, but with unprecedented efficiency.
Right. All thanks to this clever idea of integrating reasoning and memory consolidation into a single, constantly updated internal state. Start forgetting, basically.
And the implications, they feel pretty huge. We're talking about AI agents that could be genuinely useful for much more complex real-world stuff, right?
Absolutely. Think scientific research, wading through mountains of papers, legal analysis, tracking complex case histories, truly personalized education adapting over long periods, even advanced customer service that remembers your entire history without getting lost.
And crucially, it makes these powerful capabilities more accessible. Lower compute and memory needs mean.
It's more sustainable, cheaper to run. It potentially brings advanced AI within reach for smaller companies, researchers, maybe even individuals, not just tech giants with massive server farms. It's a big step for democratizing AI.
Of course, no silver bullet, right? Are there limitations? Where does MEM1 maybe not fit so well?
That's a good point. Its current strength relies on environments where there are clear, verifiable rewards for the task. The RL training needs that signal. So for very open-ended creative tasks or situations where success is really ambiguous or subjective, MM1 might be less suitable as it stands today. There's still work to do for those kinds of fuzzy problems.
Makes sense. It thrives where the goalposts are clear. Okay, so maybe a final thought for you, our listener, to chew on. Imagine AI agents learning not just facts, but the skill of understanding. Not by remembering everything perfectly, but by mastering this art. MEM1 is starting to show knowing what's vital, what's noise, and how to weave it all together into a coherent picture that evolves. If AI can master smart forgetting, what other incredibly complex problems that overwhelm us today, might become solvable?